Hi guys, we're looking at our next set of matrices notes, and we're really using matrices to solve some word problems, application problems. And so we've solved all the different types of the application problems that you're going to see today, and I'll also post some other videos about resources you might want to use to help you look up some things about application problems and things like that. So again, we're going to use our calculator. We're going to use RREF to help us solve all of these system of equations that we're going to create. So as a reminder, when you are solving an application problem, there's a few things that we're looking for. So we're going to make sure that we look for defining your variable. If you have two variables, you need two equations. If you have three variables, you'll need three equations, and so on. So you have to define your variable. You need to write your equations, show some work, and we'll talk about that, to justify what you've done. And then you want to make sure you write a conclusion sentence, or a conclusion statement, I should say. So in our first problem, a father is 4 times as old as his daughter. In 12 years, he will be 2 times as old as she is. How old is the daughter now? So I have two unknowns. I let X be the father's age and Y be the daughter's age. Let's take this first sentence. A father is 4 times as old as his daughter. So father is X, is 4 times as old as his daughter. And ask yourself, does that make sense, that dad's age would equal 4 times daughter? In 12 years. So here's what you need to think about. Not only has dad gotten 12 years older, but the daughter is also going to get 12 years older. He's going to be twice as old as she is. So I would take the daughter's age and multiply it by 2, and that's going to equal the dad's age. So I now have created my two equations, and we know we could use substitution, we could use elimination, we could graph and find the intersection point, we could use inverse matrices. We're going to stick today with using RREF. So in order to use RREF, everything has to be nice and lined up. So I'm going to take my first equation and rewrite it as X minus 4Y equals 0. In my second equation, I'm going to go ahead and distribute here. So X plus 12 equals 2Y plus 24. And then let me come up here and put everything on one side. So X minus 2Y equals 12. So now that everything's lined up, I can write my single matrix. And I know that here's my work. I'm going to be taking RREF of that matrix. So let me come to my calculator. I hope it doesn't die on me as we're doing this. Second matrix over to edit. It's a 2 by 3. And I just enter the coefficients. Go back to my home screen. Second matrix over to math. Choose RREF and matrix A. So remember, this is saying 1x is 24. So in other words, dad's age is 24, and the daughter is 6 years old. So just kind of write a basic conclusion sentence. So as I look at this next equation, I've already taken time to read it, and I know that I have two variables. I need to find the money that's invested in the 2.5% account and the money that's invested in the 4% account. So once again, since I have two variables, I'll need two equations. Well, one of them comes from knowing how much money was invested in all. So if I take the money invested in one account and add the money invested in the next account, in all, we invested $200,000. I know another total. It says that per year, I'm getting $5,225 off interest. Now, where does that interest come from? Account X earns 2.5% interest. So to find the amount of interest earned off that account, I'll take 0.025 and multiply it by x. For my other account, I'll take 0.04 and multiply it by y. So I have a total amount of money, and I have an equation for the interest earned. And this is actually set up in a way that I can go straight into writing it as a matrix and doing RREF of this matrix. So I'm going to go ahead and do that over here on the side in my calculator. And then again, for showing my work, I'm going to write the matrix that I've gotten. So, she invests $185,000 in the 2.5% account, and $15,000 in the 4% account. Alright, as I look at the next one, it says Mr. Belding, bonus points for who knows whoever Mr. Belding is, has 32 coins in his pocket. He has only dimes and quarters, but he has a total of $6.05. How many quarters and dimes does he have? So we have two variables here, and just kind of go sentence by sentence. So first off, I know how many coins he has in total. The number of quarters plus the number of dimes has to equal 32. I know an amount of money that Mr. Belding has here. So how much is each quarter worth? Well, each quarter is worth 25 cents. And each dime is worth 10 cents. And so that will give me my second equation. So 32.25, 0.10, and 6.05. And I'm going to do RREF here. So I'm going to come over to the side and type this into my calculator. And I'm getting 1019, 0113. So I go back and look. This means that there are 19 quarters and 13 dimes. All right, let's turn the page. We've just got a couple more here. So let's go ahead and take a look at this chemistry problem. A mixture problem. So in a chem lab, the concentration of one solution is 10% hydrochloric acid. The concentration of a second solution is 60% hydrochloric acid. In all, we need 50 milliliters, and of that 50 milliliters, 30% is hydrochloric acid. So I've defined my two variables here. Now I'm mixing these two containers together. So I know one of my equations will be the amount in one bottle plus the amount in the other container has to equal, and when I mix them together, I need 50 milliliters. So this is your total solution. That's an equation for total solution. My next equation is going to represent amount of acid. So if you go back and look, I know of the 50 milliliters, 30% of it is acid. So 50 times 0.3 is 15. I actually know that 15 milliliters will be hydrochloric acid. So where does that 15 milliliters come from? Well, 10% of X is acid, and 60% of whatever Y is acid. So I've now created an equation that represents amount of acid, which means I can create my equation. So I'm going to go ahead and put it in my matrix. Again, 15 is 50 times 0.3. And then I'm going to come to the side and put it in my matrix. So, in other words, 30 milliliters of the 10% solution and 20 milliliters of the 60% solution are needed. All right, last one. So we have a boat that's going upstream. Now, upstream means it's going against the current of 24 miles on the Illinois River, and it takes 7 hours. The trip back, so that means the current's going with the boat, takes 6 hours. Assuming the motorboat maintains a constant speed, what's the speed of the current in the river? So here we know that we have this equation that says distance equals rate times time. We also know we have two variables, so think about it. We need something for going upstream, and we need an equation for downstream. So our distance upstream and downstream, it's the same. We've got going upstream, our time is 7, going downstream, our time is 6. But rate is where we have to think a little bit about. If we're going upstream, the water or the current slows us down. So we would take the speed of the boat and subtract the current. Going downstream, it's going with us, so we would be adding. Now, in order to type this in a matrix, I do need to line everything up in a certain way, so I'm going to distribute 7x minus 7y equals 24, 6x plus 6y equals 24. Let me put this in a matrix. Whoops. And let me take RREF of this matrix. So I'm going to come to the side and type this in. Ooh, I made a 7 by 7 matrix over here. And I did end up rounding a little bit there. So let's make sure our answer makes sense. Would it make sense that the boat would go 3.7 miles per hour and the boat would go 0.286 miles per hour? And it does. Again, I did round. So the boat speed is 3.714 miles per hour. And current is 0.286 miles per hour. And that's the end of our video.